And then moving to topic 4, this is application stuff. So this is the multiplication and the addition just under the topic of geometry, basically. So number 19, we are looking for the area of a rectangle. First thing I would recommend doing is just making sure that you know those formulas. So the area of a rectangle is length times width, and then you've got these things measured on here. So it gives you the area, and then you're kind of working its way backwards to the width. All right, so we have the length right here times the width equals some value that we've got right here. All right, so we have, if we know, let's see, if we want to solve for width, the way that I would recommend doing this is taking the width and getting it by itself by dividing both sides by L. So we would know that width is area divided by length, just using this formula right here and getting the W by itself. So in this way, we know the area, we know the length, we can set it up in what will turn out to be a complex fraction. Okay, so the width is the area, which is this beautiful expression right here, divided by the length, which is this one right here. And this turns into a complex fraction that we were literally just working on. All right, so for each one of these, we want to get a common denominator. So this one, the n and the 2, the only possible common denominator would be 2n. So this one, we're going to use n over n. This one, we're going to use 2 over 2. 4n and 2n squared. So common between 4 and 2 would be 4. Common between n and n squared would be n squared. So we want them each to have a denominator of 4n squared. So this one needs an extra n, and this one needs an extra 2. And then they'll both have a 4n squared. Okay, so let's rewrite this. So this one, distribute the 2, we will have 2n minus 6 plus 7n over our new common denominator of 2n. That's the numerator. We can still simplify that up just a little. This one, n times 3 minus 1 times 2 over our common 4n squared. Okay, so that's step 1 with the complex fractions, is to get them to each just have one piece, numerator and denominator. Then we would turn it into a multiplication problem. So this, the 2n and 7n would be 9n. So I have 9n minus 6 over 2n, and then multiplied by the reciprocal of this. So the 4n squared flips, trades with the 3n minus 2, and then you simplify. So this now turns into a multiplication problem where you factor, reduce the monomials, cancel any common binomials. So the only thing I see to factor here is the 9n minus 6. You can take out a common 3, and then this is what it leaves you with. And then everything else is either a monomial or is not able to be factored. So monomials first. So 4n squared, 3, and 2n, those are our monomials. So the 4n squared divided by 2n reduces down to leave a 2n behind. And then common binomials can cancel. So this, the 3 and the 2n would just be 6n. So it actually ended up being a pretty simple expression for that width. All right, number 20, the volume of a rectangular prism. Volume of a prism is length times width times height. So I'm taking all 3 of those expressions and just multiplying them together. It doesn't really matter which one you choose to be the length, width, and height. I would call this the length, this the width, and this the height, but obviously it's not going to change a thing. So we have the length times the width times the height. I'm going to factor them as I'm writing them down. So the length, the x squared plus 13x plus 42. We have x times x to give us the x squared. Multiplying to 42 and adding to 13 would be plus 6 plus 7 over this, which is a monomial, so it doesn't factor any further, times the width. The numerator is a monomial, so it doesn't factor. The denominator has a GCF, so I can take out a 5, and after I divide by 5, it leaves me with x plus 7. Times the height is this, so the numerator, x squared minus 9, that is a difference of squares. And the denominator here, the x squared, I start with x times x, and multiplying to a negative 18, adding to a positive 3. That would be a positive 6 and a negative 3. Okay, so start with the monomials. We have a 3x, a 6x squared, and a 5. Those are the only monomials. So 3 over 6 reduces down to 1 over 2, and then x over x squared reduces down to 1 over x. Okay, and then last step to simplifying is any common binomials. can cancel out. Okay, so look across the numerator. We have an x plus 3 left over. And then the denominator, we have a 2, an x, and a 5. So that would be a 10x. Remember, nothing can happen with those x's because you can't just take a piece of the binomial without the whole thing. And 21, the perimeter of a triangle. Perimeters are super easy. You're just adding the 3 sides together. So it would be like a plus b plus c. So just adding all 3 of these pieces. All right, so let's take c over c plus 5 plus 4 over c minus 5 plus, and then this one I am going to factor the denominator down because it's the difference of squares. So c squared minus 25 is c plus 5, c minus 5. So you can see since it's perimeter, I'm adding, and since it's addition, I need to make sure that I can get the same denominator for all my pieces so that I can add them. So my denominator, these 2 pieces have a c plus 5, these have a c minus 5, which means that these 2 pieces are going to be the common denominator. So this piece needs to be multiplied by a c minus 5, top and bottom. And this one needs a c plus 5, top and bottom. Then that way, if you look across, I have the exact same denominator for all 3 of these pieces. So I can combine them into one big fraction, see what I can do to combine like terms. So here, distribute the c. I'll have c squared minus 5c. This one, distribute the 4. And this one didn't have any changes, so this numerator just stays. And then the denominator is that factored c minus 5, c plus 5. So let's combine like terms in this numerator. This is the only c squared. For c, I have negative 5, positive 4, and positive 7, and that would be 6 when I add them all up, 6c. And for the constant, positive 20, negative 15 would be a 5. And this denominator is just staying the way it is until I get through my next step. So next step is to factor that numerator if I can. So to multiply to a 5 and add to a 6 in the middle, that would be a positive 5 and a positive 1. And you can see there I have a matching binomial that I am able to cancel. So these common binomials can cancel, and this leftover expression would be my final answer for the perimeter.